Hello, and welcome to this lesson on factors that can limit the yield of a chemical reaction. In today's lesson, we will understand the factors that can limit the yield of a chemical reaction, including reversibility, losses during separation, and side reactions. So far, we've talked about calculating percentage yields using this formula. We also discussed the theoretical yield, understanding that it is the maximum amount of product that can be produced in a chemical reaction, assuming that all reactants are converted to products without any losses. We saw through various examples that the actual yield comes out to be less than the theoretical yield. In fact, this is actually always the case. Actual yield is never equal to theoretical yield, and hence, percentage yield is never truly 100%. In this lesson, we will understand the factors that limit the yield. This will advance our chemical understanding by helping us identify practical challenges in chemical manufacturing processes and how to optimize reactions for better efficiency. Let's dive into the various factors that can limit the yield. Firstly, yield can be limited by the purity of reactants. More often than not, reactants used in a lab contain impurities. Imagine using dirty sugar with sand mixed in for baking cookies. The sand doesn't contribute to making cookies, so you end up with fewer cookies than if you had used pure sugar. Similarly, in a chemical reaction, impurities in reactants can lead to lower yields because they might react differently or not at all. Next, we can look at the reversibility of the reaction and how this affects yield. A reversible reaction is one where the products can react to form the original reactants again, like a two-way street. This means that not all the reactants turn into products because some are always turning back, limiting the yield of the reaction. We can also look at side reactions. In many cases, reactants can participate in unwanted side reactions, forming undesirable products. For example, if burning something, carbon monoxide may also be formed alongside the expected carbon dioxide. These side reactions consume some of the reactants, leaving less available to form the target product. This lowers the actual yield of the desired product. Another factor that limits yield is the possibility of losses during separation. Once the reaction is complete, the product must be separated and purified from the reaction mixture. During these processes, some product can be lost. This could be due to incomplete separation or products sticking to the apparatus. For example, during filtration, some product may remain on the filter paper and not pass through. These losses mean that not all of the product accounted for in the theoretical yield is actually obtained. Similarly, losses during transfer can limit yield. Conducting a chemical reaction often involves transferring substances from one container to the other. During this process, some product may be left behind in the original container. Furthermore, spillage could occur during the transfer. This leads to loss of product, which lowers the yield. By understanding and calculating the percentage yield, chemists can optimize reactions, improve processes, and ensure that resources are used as efficiently as possible. In today's lesson, we delved into the factors that can limit the yield of a chemical reaction, focusing on 5 aspects: purity of reactants, reversibility, side reactions, losses during separation, and losses during transfer. This understanding is crucial for optimizing reactions in both laboratory and industrial settings.